Here we have another diagram where we're dealing with a complicated figure, kind of different triangles layered on top of each other. And so again, we're going to use that technique of just breaking those layers apart. So I'm going to first start with the big triangle here. So this one. And so I'm just going to draw everything that I know that's in there. And I'll point out one thing that might not be entirely obvious in a moment. Now, what I was going to point out that's not entirely obvious is this angle right here. And we have a couple of ways that we can go about this. I'm actually going to do it in a really algebraic way. And that is that this angle right here is that angle right there. And so what does it equal? Well, if I take this angle measurement m and this angle measurement in, and I add them together, that totals up to the entire angle here. So I'm actually going to put that right here. And since it's isosceles, I know that this angle is congruent to this angle here. And from this, I actually can develop an equation, and I'm going to do that. Now, this is one technique. It's going to be pretty algebraic, but it's going to kind of offload everything into the equations. So we're going to add up all three angles and set them equal to 180 degrees. And let's go ahead and clean this up, adding up the like terms. And I'm going to go ahead and stop there. I noticed that I have two unknowns, both m and n, so I can't currently solve this. I could clean it up a little bit more, but I'm just going to hold off on that for right now. Because I know that I'm going to need more information if I want to find these values. I'm also going to go ahead and fix this part right up here, because we're clearly not looking for x and y, we're looking for m and n. There we go. So now that I'm kind of stuck with that first triangle, I'm going to pull out the second triangle. And while I pull it out, I'm going to point out the fact that this right here says that it's a right angle or a right triangle. Now looking at it, it clearly is not a right triangle. That being said, it doesn't matter. Remember, if I put a marking there and say that is a right angle, what I'm saying is my drawing isn't good enough. Believe me, that's a right angle. In this problem, it is. The drawing's just not to scale. All right, so let's go ahead and draw this out. Okay, we have that the smaller angle down here is in degrees, that this is an isosceles right triangle, and that we have a right angle right up here. Well, since it's isosceles, I know that those opposite angles are going to be congruent. And from that, I can come up with an equation. In degrees plus 90 degrees equals 180 degrees. Now this one only has one variable, so I can in fact solve it. Perfect. So now I found the value of n, which is part of what I was looking for. And what I can do is I can come back up to this equation that I just kind of set aside for a moment there, and I can replace any of the n's in it with 45. Then I'll go ahead and write out everything else and see if this equation is now solvable. And you know what? I'm only seeing one variable now, so yeah, I can totally solve this. We'll combine like terms. So that's 90 degrees plus 40 degrees, so that's a total of 130 degrees. All right, so now I believe that I have the value of both m and n. Hopefully you're guessing it. What I'm going to do now is I'm going to plug those back into the original equation and make sure that they make sense. So in this problem right here, again, I do know that this is isosceles. So if this is m and this is n, so is this. And I probably should have mentioned that earlier. And let's plug in those values here. All right, and so my quick check here, 45 plus 90, well, that's 45 and 45 is 90. Yep, that adds up to 180. So the red triangle is good. And let's check the big triangle here. And again, I could just check that over here as well. It's entirely up to you, but I wanted to bring it back to my original equation here. And so this whole angle here, well, that's just 45 plus 25, which is 70 degrees. Same thing here. That angle is 70 degrees. And so now I have 70 plus 70, which is 140, plus another 40. Yep, that's 180. So I've now visually just really quickly checked to make sure that those values I had satisfy that condition that all three angles of a right triangle add up to 180 degrees. So I know that I'm good.